Thank you very much. Thanks for having me here today. Another great local, regional, wonderful event, and I'm happy to be a part of it. So thanks for having me. We have an hour to talk about window functions and SQL Server. It's technically less than an hour. So I'll go fast. And if there's any questions, we'll save them for the end. If there's more, we can save them for afterwards. Find me on LinkedIn. I will post the slides and the demos and everything afterwards. So we'll have all that information available. So this is me really quick. I'm a Microsoft Data Platform MVP. I have done a lot of writing and speaking, and I enjoy doing all this. I love supporting events like this, and I love being a part of the data community. This is fun to me. And I'm hoping to bring back our SQL Saturday event that we used to have out here soon. So if you happen to be really far away and you want to come on to our event, you're more than welcome. Oops, don't want to do that. All right, so here's what we're talking about today. We're talking about window functions in SQL Server, but they apply everywhere. Window functions are available in Postgres and MySQL and really like every flavor of SQL you could find. So they're not unique to SQL Server, but everything here today will be in SQL Server. So we'll do kind of the intro to how they work for anybody here who's not very familiar with them. But I promise I will dive more into details about how to use them and what they look like and how we can use them in analytics and some common questions as well. Which we can cram into this time slot. I will work on that. And I'll also talk about a lot the syntax, the unbounded preceding, current row, unbounded following syntax. That syntax is a little trickier. Not everyone uses it, but I do highly recommend using it, especially when you are not getting the results you expect. And we'll talk a bit about performance at the end and along the way, and then we'll wrap up, take questions, and then you'll get to wrap up your event, and I'll just begin my day because it's 6 in the morning over here. So that chuckle at my ability to be awake in the morning right now. What are these things? What are window functions? At the core, all they're doing is allowing you to perform calculations within a data set and to customize those calculations heavily. And what makes them unique is you define a window. So you aren't just doing a group by, you're not just aggregating your data, but you're literally saying, all right, within my data, for every row, you're going to perform a calculation. And I'll tell you exactly how to perform that calculation, how to group the data, how to order the data. And this is all independent from the where clause, the group by, everything else in your query, the order by at the end. That allows you to do a lot of really cool things that otherwise are challenging, that require a lot of SQL or a lot of extra queries or really poorly performing things. If anybody here has ever calculated a median, for example, had to make a median and didn't have a window function available or some easy to use function, it's not a lot of fun. You have to like order the data, then grab the middle, order it backwards, or number it, stuff like that. It's not pretty. Window functions have evolved a lot, and that's huge. You can read about them. Every version of SQL Server, they improve. We have more of them and more options available, and they get better, which is a great thing. For many of the more complicated stats functions, using a window function will require less T-SQL, and it will perform better, which is wonderful. They're very, very flexible. You can do so much with these. You can get creative too and do a lot of very interesting things. And so don't ever feel like you're constrained and you can't do certain things. You can do almost anything with these kinds of functions. And they can make your code smaller, simpler, and easier to read too. And that's always a good thing. The key really to the beginning of this is not the same as aggregation. Doing a select and then having a group by, these are very different things. And we'll demo it, make a lot of sense of it. We'll talk about it. When you apply a group by to your query, it applies to everything in your query. So you select some data from a table, and then you group by. Whatever you group by affects everything in the query. Window functions aren't like that. They apply to every row in your data set, and you're not aggregating to do it. And therefore, you can have multiple window functions in the same query, and you can have all different windows for each one, and that's fine. You can really customize and have a lot of different calculations in each one. If you do group bys, that's great. If you add subqueries to your query within a group by, it can get pretty expensive. Whereas the window functions typically aren't going to harm your performance more than the data they have to read and stored at their core. Group by gives you flexibility. You can do some cool things like grouping sets and whatever. But in general, once you group by a few columns, you've group by them and you're done. You can't add additional group bys in there. You can't have 4 of them. You've got to have separate queries to do those. And you can only have one group by per query. I mean, it's obvious, You can't have more than one. I can't say group by this and then also have this group by over here. You need different queries or subqueries or something like that. So the key here is I can have many window functions in one query, and that's really, really nice. What can we use these things for? I've just talked about this thing that you probably have used before, maybe you haven't used before. What is it good for? It can do a lot. The most common use is generating row numbers. Probably the first thing anybody ever does with window functions is row number over whatever. You make row numbers. You number your data set. If you don't have an identity available, you want to generate row numbers. You want to rank things. Very, very, very easy way to do it. But you can do a lot of other cool things too. You can get previous and next values from your data set. So I can literally say, hey, give me the last value or the next value or 3 values from now. And you can just do that and it works. You can have correlated calculations. You can do all kinds of complex math and stats. I could do mins, maxes, averages, medians, standard deviations, variances, ranks, percentiles, all kinds of stuff. I have a really cool presentation out there on gaps, islands analysis, and I've written about it, all free stuff. You can just look up my name, gaps, islands, and read about it. You can go really far with this. So you can take it and write some crazy SQL to do some really amazing calculations. That's what that was. So there's really very little restrictions and a lot of flexibility here. So they're useful for a lot. And there's a lot more too. I can probably list like 10 pages of things that these are useful for. So very, very handy, very flexible, wide-ranging applications. I've said window functions a bunch of times, but what's the window? What am I even talking about a window? And what a window is a grouping of a row of rows. So you have a data set, and in that data set are rows. You just have rows, right? That's what every data set is made up of is rows. And for each row, you're gonna have a window around it. It could be all the data around it. It could be some of the data around it, but it's relative to each row, and you can customize it a lot. And so you define the window and decide how it's going to work. And I'm going to kind of illustrate that. I think pictures help a lot here. No, not the Windows logo. So here's an imaginary data set. I made it up. And there's some accounts, there's some order amounts. It's very typical sales kind of data, right? You have a salesperson, you have a mailing state, order number. So this is a pretty normal data set. You see this kind of stuff all the time. So let's say I want to perform some calculations in here using window functions. I define the window. So what is it? I'm going to use some words here that'll sound complicated at first. They'll get simpler as we move through. The current row is each row in the data set. And so we're going to perform these calculations for every single row, just like any calculation in a data set. And so let's say that yellow row there for Google 1008 is the row I'm looking at. How can I define windows around it? If I want to have unbounded preceding, now preceding and following and current row are kind of the terminology used here. Preceding is the window before your current row. Following are the rows after your current row, and current row is your current row. So let's say I have an unbounded means you go back to the beginning of the data set. So the syntax is going to look like rows between, and then your preceding, and your current row, and if it applies, your following. You can have any mix of these. So this example here shows unbounded preceding and current row, which means I will get calculations that involve every row from the beginning of my data set to the current row, including it. Alternatively, how about rows between current row and unbounded following? That says, give me every row from my current row to the end of my data set. Unbounded means beginning or end. It means going all the way to the beginning, all the way to the end. I can do other cool things too. I can actually put a hard-coded number in. Not everyone knows you can do this, but you can. If you put a hard-coded number in, it will get that many rows before or after your current row. For example, rows between 3 preceding and current row would give me the 3 preceding rows, the 3 rows before my current row, and also my current row. This may sound kind of weird. You may ask, why would I do this? But when you're doing analysis, especially of monetary data, people find a lot of reasons to do this. Like let's say I have monthly sales numbers and I want to get a sales number from 3 months ago, or I want an average from the past 6 months or the average from the past 12 months. I could calculate all those separately, or I can do them all in one place. And it might be more efficient. It'll certainly be more convenient. Similarly, I can do rows between two preceding and two following. So give me the two rows before the current row, give me the current row, give me the two rows after the current row. And you can customize like this. There's a lot of ways to do this. So with this syntax, we can define a window of any size and shape that you want relative to your current row, whatever those, for every single row in your data set. So current row is really just talking about every row in your data set. Is there a question, by the way? I'm not checking the chat at all. I'm not sure if there are any questions so far.
No, all good, all good, all good.
Okay, great. So making sure. I do tend to present fast, which
Yeah,
can be
no,
fun,
it's all good.
but also wild at the same time. No problem. So you can see here we can customize the size and shape of our window to our heart's content, which is great. There is some defaults though. That syntax wasn't always there, and you don't have to provide that syntax, though in some scenarios you do, and in some scenarios you actually shouldn't. SQL Server will throw an error sometimes, and I'll talk about that later if you provide it and you shouldn't. So if you do not provide this preceding and following syntax, and you provide an order by, then the default's going to be rows unbounded preceding and current row, kind of like a running total, sort of. And so you'll go from the beginning of your data set to your current row, which for like row numbering and things like that makes perfect sense. That's the most classic use of it. Just give me a row number over order by something, and you get row numbers. Makes perfect sense, straightforward, easy to use, fun. If you have preceding and following not provided, if you don't provide it, and there is no order by, then the default will be unbounded preceding, unbounded following, which also for certain things makes sense. For example, if I'm doing a sum or a min or a max, I may just want to have that that sum of the whole data set, or the average of the whole data set, or some calculation of the entire data set, and have that alongside my data. So give me my values for each row, and then give me the average for the whole data set. So that can also make sense too. Just keep this in mind though, that if you don't provide the syntax, it's going to assume a default, and you'll know quickly if it's what you want. But just keep in mind there are defaults, and you may or may not want them. So if you don't add this syntax in there, you get what you get, and hopefully it's what you want. If not, you'll change it. I'm not going to go into this too deeply today. Almost always when you see window functions, you'll see rows versus range, rows between unbounded preceding and current row or whatever. You can include range as well, and range will perform calculations that include duplicate values, and they will change your results. I'm not going to really get into that too much today because it isn't used very much. It has certain applications that make it awesome. But people generally don't use them too much. So I'm not going to go out of my way to demo them today. I'm just mentioning it here in case you've seen it before or used it before. Cool. If not, you can read about it more elsewhere. And I'll probably make a whole article about it soon now that I've talked about it, because it's what I tend to do. So just keep in mind that it's out there. It exists. It can be useful. You may find use for it, but I'm not going to demo it today or talk about it today. Beyond that. So now we've talked about defining a window. So we have this set of rows relative to every row in our data set that we will calculate using. What can we do? The two pieces of syntax that kind of come into play now are partition by and order by. So for each calculation you're making in your data set, you can partition, which basically means a group by. It's going to take your window, all the data within your window, and it's going to then apply an aggregation to it. And so it can divide it into subsets. This allows you to do some pretty cool calculations. Like, for example, give me the average sales numbers for each salesperson or state, or give me a sum by location, things like that. And that could be within your data sets. You don't have to have a group by at the end of your query. You don't have to have multiple queries. You can simply have this in your window function and get what you want. And it allows you to basically subdivide your calculations. Like, I want to know for each region the top 5 salespeople, so rank them all. And I can just partition by sales region and do that. And then I'll get that baked into my data set. And I'm going to have lots of demos soon, I promise. Don't worry. I love live demos. They're fun, they're exciting, they keep us on our toes, they break, that kind of stuff. We all do like that. So here's how partition would look like. And that's this is the colorful mess here. You're welcome. But let's say I have row number over and I partition by account name. And I order by amount. So what I'm basically saying is I want to subdivide my window by the account, and then I want to order by the order amount ascending. So I want to know the ranking by order amount, highest first. I want to know the top orders by account. So if I look at this big, colorful, fun thing here, I can see, for example, from Microsoft, they had three orders, and there's a 1 in the middle on 1006 for $14,000. Row number 2, order 1,000, is for 10,500. And then number 3 is that one down on line 1013. And so it actually subdivided the data set by account name and then ranked it by sales. And did that for me, just using the data right here. That's what it would look like. I colored it to kind of try to help. Hopefully it's a little helpful. But for each account here, it's done this. And that's pretty cool that it can just, in a snap of your fingers, group your entire window, provide row numbers back, done, just like that. That's really convenient. Without a window function, this would be a lot harder. It'll be less efficient. It'll require more code. It'll be harder to read. No question about it. So what can we do with these in analytics? How can this help our analytic world? And the answer is it can help a lot. And analytics at its core are big data sets that we're performing complex calculations on. And that is the core of this. They can be slow, they can be expensive, and they're probably feeding further work. Machine learning, AI, dashboards, reports, all kinds of things are being fed by this data. And so having more calculations available here, having more options available, can mean less work down the line. What can we do? This big list of things, everything from standard deviations to first and last values, previous, next, averages, so on and so forth. There's so much we can do here, and I'm not even going to list them all. I'm going to try to demo a lot of the common window functions today that I'm not even going to get to them all. There's just so many, and that's fine. If you ever need more, there's more out there. So let's look at them finally, now that I've talked about them for 15 minutes. Let's look at them. This is a very quick demo of what they look like. And so the key here is this data set, I intentionally have no where clause. You can obviously have a where clause on your queries whenever you need. I left it out here on purpose. There's no group by, there's nothing down here. All it is just I join two tables together. I return a little bit of detailed data here about the order. And then I have a whole bunch of window functions you can see. And so I'm going to run this and then talk about the results a little bit and look at the syntax. So here's what I've done. You can see that for each of these, I partition by the sales order ID. So I'm taking a window, and I did not provide the detail for all of this, the preceding and current row stuff. That's fine. But I'm grouping within this window by the order. So for each order here, these first three, I'm grouping by them. So give me a count grouped by sales order ID. So if I go down here, I can see for each sales order, I now have an item count. I can see very clearly I order, here's 12 rows in this one sales order, item count 12. So I very quickly just got a count of how many detail rows are there per sales order, how many detail lines are there. I did it for each one, and I can see here throughout here that item count is there now, in line with all the rest of my stuff that I need. Similarly, I said, hey, can you also give me the min unit price? Give me the smallest unit price and the max unit price. And so for each order, I also got the lowest price and the highest price. And if I were to scan around here, I can see, oh, there's that lowest price, and oh, the maximum price, there's maximum there. You can go through the unit prices and figure it out. Have it there. So lots of cool things. What else can I do here? I said, give me a row number and order by the sales order ID. Why would you do that? It's a little weird. But okay. I went here and I made a row number based on sales order ID just because I can. So now I have kind of a PK within here. I didn't partition by here because I didn't add a partition by. I'm just ordering through the entire data set. So you can see the numbers get really big as we go down. But I basically created kind of an identity sort of for this data set, one row at a time. That's it. Here I got a little creative and said, let's sum up the unit price, and I'll order by the order date. So I want to do rows between 5 preceding and current row. What's that going to do? It's going to give me a running total of the 5 previous orders and my current order. little creative, right? But I can see here some interesting numbers. There we go. That could be very useful. I may want to get an average of recent information. Do that because I ordered by date. Similarly, I can say do the sum of unit price with the same order by, and do rows between two preceding and two following. So give me the total for the two previous, the two next, and the current. Again, this is something you may or may not need, but you can do it, and it's kind of cool. And I can see here the sum is then created based on it. And I can keep going, and I can put more and more window functions in here for fun, but you kind of get the idea. The real key to this demo is that there's no group by down here, and I can just have as many of these as I want within my data set and perform calculations. And that's really convenient, really, really convenient. Let's jump back here. One of the most common and useful applications for window functions and analytics is running totals. Running totals are by their nature expensive to calculate because you need to take a data set, scan it, and order it as well. But I do two things that are computationally expensive: read a lot of data and then sort it. And this can do it in line. And without a window function, how would you do this? This would require common table expressions, lots of subqueries, correlated subqueries, things that make your T-SQL perform poorly, that require scanning a table many times. What I'm trying to say is it'll make your queries more expensive, which isn't something we usually strive for in writing SQL. And now I'm going to lean more on demo here because demo can really show how this works. Running totals are a great use for window functions, a wonderful use. And so how do they look? I'm going to run this first and then show what I have. Notice I have an order by at the end here this time. No where clause, no group by, I'm scanning the whole data set, but I have an order by down here. And so you can have window functions that partition by columns, order by columns, but then I can order by different columns or the same columns at the end if I want to. And keep in mind that whatever you order by in your window functions doesn't guarantee the order of your overall query. I can still, at the end of the day, order SQL Server based on the optimizer can do whatever it wants. So if I don't put an order by here, nothing is guaranteed. It can do whatever it wants. So never assume that the order by within a window function is going to be what comes up in your query. If you need a data set ordered by certain columns, always put an order by. Don't mess around. Don't assume. Don't guess. Guessing is bad. So here we go. So for each row, for every detail row here, I have a little bit of information, some IDs, a date, a purchase order number, a subtotal, and so on. And then I got, like before, I demoed the unbounded preceding, unbounded following. So I have an item count, so I know how many items there are. Let's look at this one order here. I then said below that, instead of unbounded preceding, unbounded following, I said, give me the same count, order by the detail ID in this case. So just give me the order based on the PK. Rows between unbounded preceding and current rows. So by doing that, the window is all the rows before my current row and my current row. If I look here, I can see I now have an item count running total. So I can see this is my first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, tenth. Nothing too fancy here. This probably didn't blow anyone's minds. But we can do better things. For example, if I do a sum over like this, and I provide no window, because to sum, it's going to assume unbounded preceding, unbounded following, or in other words, if you look over here at total unit price, it's summed up everything, which is cool. It summed up all the unit prices for everything in this order. That's nice to have. It could be very useful. Oops, sorry, we're right here. There it is. But let's say I did put a window here, unbounded preceding, unbounded following. Let's say I decided to say rows between unbounded preceding and current row, like earlier. So give me the sum of unit price by order, order by that detail ID, and I want to go between the beginning of my window and my current row. That'll give me a running total for my unit price here. And this is more useful, right? Now I can see that for each order that came through, I'm getting a running total of my orders. And you can see, obviously, the final row is the total unit price because the running total of the whole data set will be the sum of the whole data set. No problem there, nothing weird. But this is great though. Running totals are wonderful. They're extremely useful in analytics, extremely useful in general for displaying data because I want to know, and it can be, you can apply this to anything. You can say, give me my sales by day for the current quarter and begin summing it all up. Number of orders received per hour, per day, things that you can then get a running total of that and have that as you go through your data set. So as you're walking through your data set, you're adding up as you go, which is very useful. I want anybody here to think about, have you ever calculated median in a data set in SQL somewhere, in any flavor of SQL data platform you want, and you didn't have a window function available? If you've done this, you'll remember it. It's not fun. It requires subqueries and CTEs and joins and all kinds of messy stuff. And it's very easy to make mistakes. And it performs terribly, too. I remember having a data set a while back that had billions and billions of rows. I needed medians, and I couldn't get around it. And I tried using SQL to do it, and it was painful. But as soon as I was able to use a window function, as soon as I had the version of SQL Server, I believe it was 2012, I think. Don't hold me to that, please. It became easy, it became fast, and my life got better. Median just really tells you I want the middle value for a data set. It's very commonly used in stats, and it's a pain to calculate on your own. And if you do it on your own, you just do trickery like number a data set, reverse it, number it again, find the middles, join them, things like that. There are two functions in the window function world that will do this for us. The first one is percentile cont, and the second one is percentile disk. Cont stands for continuous, and that will provide you a median, and that median may or may not be in your data set. If you know stats, you know that a median, when you have an odd number of values, will just be the middle value, you're done. And so it'll be a value in your data set. But if you have an even number of values, let's say you have 10 values, there is no middle. You have 5 here, and nothing in the middle. So there's different ways of doing it. Some people take two middle values and average them. Some will take one of them that's more relevant, the standard deviation, whatever. There's different ways to do it. Here you're choosing between those ways. You're choosing, do I want to get a value in the data set that's closest to the middle, or do I want to calculate the average of the two middle values, which is the cont? So how does this look? Here's our data set from before. I'm sticking to really simple data sets on purpose here. I don't want to get complicated. I don't want to provide you with, billions and trillions of rows of complicated data. I want it to be easy to understand. I put a few other things in here too for fun, just to kind of help us with boundaries. So here's our row number here. So I numbered our rows. So within each of our, oops, there we go. Each of our orders, I have a row number. And now I can say, all right, give me the median and pick a value on my data set. And you got to provide this within group and what to order by. So order by unit price tells me that the median is going to be based on order price. I want the median order price. And then I can add my partition by over here if I want to. You don't have to, but you can. I'm partitioning by order. So I want the median unit price per order. So if I look here, I can see the median is this 2024 value. I'm calculating it for the whole data set here. So for each row, I just have this one value calculated. It's not a running total or a running median or something like that. And I can see that makes sense. I can see the middle few values here are that value. In this case, the continuous is the same. There is no question here. The middle values are all the same. You'll notice I have a decimal in here, 0.5. You can change that if you want. This is a percentile. And so you could change it. Putting 0.5 gives you the median halfway through my data set. If you wanted a quarter way through, do 0.25. If you want 3/4 of the way through, do 0.75. If you want 2/3, do 0.666666, whatever, and so on and so forth. I did demo that here. I said, okay, what if I want to get a percentile at the quarter point? I can do that. And there it is. That 20.1865 value, there it is. It's about a quarter way through the data set. Or 3/4 of the way through. There it is. I can see in the data set right there. I can similarly, if you want, you're probably curious, what if I put 0 or 1 in? If you put 0 in, you get the first value. If you put 1 in, you get the last value, which I can confirm using first value and last value. There's two other window functions that are kind of cool. First value gives you the first value in a window. Last value gives you the last value in a window. That sounded kind of silly now that I said it out loud, but it's what it does, and it's useful. But you may notice also the last value here, it became a running sum because I didn't provide the window. So first value is always the first value because it's the first. But because I didn't provide the rows between syntax for this, it assumed rows between unbounded preceding and current row. And it did a running last value, which is kind of cool, but it's actually just the current value. So that was a little awkward. I added the additional syntax and I said, oh, right, rows between unbounded preceding, unbounded following, give me the last value for real of my entire window, and it did. So I can see that last value is here now, and not any awkward running last value, because a running last value is just my current value. So just a random point that if you're not getting the values you want out of your window function, add in the syntax. It's pretty well documented. It will definitely make your numbers correct. As long as you have the right preceding and the right following, you'll get what you want. In this case, I wanted unbounded everywhere. I just want the entire window. Give me my calculation. Done. Cool. So you can do medians, you can do percentiles. They're really easy to calculate, and they're really efficient compared to most alternative methods. How about ranking? Ranking is very, very common. I use it a lot. I very often in the server and hardware world, hardware in quotes, it's always cloud hardware these days, but in the hardware world, I may ask questions like rank servers based on which ones have the most disk usage or the highest CPU or the least memory usage, things like that. You can do it in other data sets as well. Rank my salespeople based on who sold the most. Rank my accounts based on which are most active. Rank my employees based on efficiency, whatever you can rank. And ranking is really easy with window functions. It's really efficient, and there's lots of ways to do it. So we have 3 different functions available that can help us, and they're all a little similar. They all behave kind of like row number in some ways, but you get more flexibility. We have rank, dense rank, and n-tile, and I'm just going to demo them because it's easier to demo than talk about these things, I think. I'm out of order. I out of ordered things. All right, so live, we'll just go down here and take this. Just in case anyone's wondering, I haven't done this presentation before, so you can chuckle at me while I fix the out of order stuff that I have going on here. All right, here we go. Ranking functions. They don't allow you to have a window frame provided. They will rank an entire data set. It's how they work. You're ranking a whole data set. You're not ranking a subset. It's just not possible. If you try to include the frame details, the unbounded preceding, following, current row syntax, it will just throw an error message. That's what it does. So we'll run this query and talk about it. And I spoiled some syntax here by using the Windows syntax. The Windows syntax, which I'm going to demo on the next slide, see I have some out of order stuff going on here, you can chuckle at me, allows you to define a window and reuse it. It basically just makes things less wordy up here. So we'll look at our data set here again, like before, and we can look at ranks. So let's say I take some data and I want to rank by unit price. So I want to rank over my order by unit price. It's going to create a rank here, and it's going to be a number like 1, 2, 3, 4, 5. And what rank will do is this is kind of a common problem you have in sports. If you have a sporting competition and 2 people tie, what do you do? Do you have first, second, third? Or do you have first, first, third? Or do you have first, first, second, third? What do you do? When you use rank, it will skip numbers when there's ties. So if I have 5 items being ranked, it will say, oh, there's a tie for first. We'll have 1, 1, 3, 4, 5. And those will be your rankings. So when you use rank, numbers can get skipped. And so if you rely in your code on having every number represented, don't use rank because it will skip numbers. And if I go back later and say I need number 2 won't be there. You'll have 1, 1, 3, 4, 5. Dense rank behaves a little differently. Dense rank will say you can have ties, and then we'll just keep numbering. And so if I have 5 people and the first 2 tie, I will do 1, 1, 2, 3, 4. So these will return fundamentally different results. And you will see those fundamentally different results here as well. You can see in some cases, the rank is 6. Other cases, it's 5, then 6. You can actually look at this and see how we have this big tie here. Big tie, 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 tie. That makes the numbers jump. And so keep that in mind. You can see how the numbers jump. 1, 2, 3, 4, 4, 5, 5, 5, 6, 6, 6, 6. That's the dense rank. The regular rank, I would get 1, 2, 3, 4, 4, 6, 6, 6, 9, 9, 9, 9. So we skip numbers. Just keep in mind that rank will skip numbers, dense rank will not skip numbers, but it will order your data based on whatever criteria you provide. What is n-tile? N-tile is kind of cool. This can break up your data set into tiles, basically. I did it here in quintiles. You can put whatever number you want here. 5 will break it into fifths. So take my data set and rank it into fifths. Who's the top fifth, bottom fifth, the middle, second, third, and fourth fifths? You can break it into fourths, halves, whatever you want. This is very, very common in testing and evaluating of systems where I need to know top, second grouping, third grouping, fourth grouping, bottom grouping. Now I know who did the best, who did the worst, what came in first, what came in last, and I want to group it. And I can see over here that that did work. So for this one order here, I can see that it ranked them. I have some 1s, some 2s, some 3s, some 4s, some 5s. And obviously, if my number of rows is divisible by 5, then it's gonna just have to do the best it can at ranking. A percent rank is very similar. It will simply provide a 0 to 1% rank for each value. So within the data set, what percentage is it in terms of its value? How high is it in the data set? Is it the top value? Is it the bottom value? You can see that here, that the bottom value will be like a 0, and then that percentage goes up. If there's ties, there's ties. You make your way up to the top value. The last one I have here, which is a little awkward, the cumulative distribution is going to be an average the number of rows with values less than or equal to the current row divided by the total. So it's going to provide a different distribution that goes from greater than 0 to less than or equal to 1, and it will look a little different. Which one of these you want will depend on what stats you're calculating and the kind of work you're doing. Again, there's limitations here. If you're not quite sure what they do, you can look. There's lots of documentation on this. But the point of all this here is that we can rank with extreme detail our values in a window. And you can get whatever ranking you want. If you can dream it up, you can create it here. I promise. You can have whatever window you want. I defined one window and reused it, which I'm now going to actually demo now. This was a mistake of mine in my presentation. I apologize. It's new, so things happen. You can chuckle. The window clause is a convenience clause. I'm introducing this here because it's handy. It can reduce the amount of code you write. This is not a performance optimization. It will not change performance. It will not adjust the results. Your results will be the same. The whole point of this is cosmetic. This is a way to reduce the size of your code, make it cleaner, and make it less likely you'll mistype something or make a mistake. It improves the maintainability of code, especially when you're repeating the same window over and over. If you have 8 window functions with the same window, you type the same thing 8 times and change it 8 times, mistakes can happen. Now I'm going to demo this for real, the window clause. So here's how some SQL would look without it. I'm writing my window functions here, and I have a partition by, rows between unbounded preceding current row, partition by order, rows between unbounded preceding current row, partition by order ID, order by sales order detail ID, all the same window over and over and over, rows between unbounded preceding and current row, same thing over and over. Well, what can I do to make this more efficient? I can go ahead and take that window that I defined here, this big thing right here, and put it down here. And I can say window, I can give it a name. I called it running total here. I call whatever I want, doesn't matter what. As, and then here's my window. Partition by sales order ID, order by sales order detail ID, rows between unbounded preceding, and current row. So I put my window here. And then up here, I simply said count star over my window name running total. Sum unit price over running total. This is a new 2022 feature, by the way. Max modified date over running total. What you note here is that this looks really clean now. It's easy to read, easy to understand, and if I wanted the details in my window, I just go down here and look at it and figure it out. It's right here. These are logically identical. I did not make this perform better. I did not make it return different numbers. All I did here was say, take my window, put it down here, and make my code cleaner. That's all. I'm going to use this during the rest of my presentation to clean up my code a bit. You can use it if you want, but you don't have to. It's 2022. If you don't have it, no big deal, but you might find this useful if you use a lot of window functions. All right, here's some fun stuff we can do. You can actually pull out of a window specific values, just a value, pluck it out, and get it. These are lead, lag, first value, and last value. Lead can get a previous row, which is kind of cool. Lag can get a upcoming row, a following row. First value can get the first value in a window, and last value gets the last value. These are kind of neat because they're not making calculations, they're just grabbing a single value, but it can be a very important value to you. The previous value could be very important. The first or last value could be very important to your data set. And therefore, we can demo it and look at it. So notice I continued using my Windows syntax here to clean up my code a bit. It's just running total syntax. This is not running total syntax, actually. This is entire window. I'm going to change it right here to make it more accurate. This is the joys of doing new things. And there we go. Let's run it. All right. So there are my results. And we can see that for each order here, I have the first value, which will always be the same. Now notice the first value in the window is based on the order by. It may not be the smallest or largest value, it's the first value. So this is not min or max at all. Simply take your window by whatever it's ordered by and give me the first value. You need an order by with it or it makes no sense. We're ordering by unit price. So give me the smallest unit price and the greatest unit price. It could be ordered by something else though. It could be ordered by anything. And so then give me my last unit price. Similarly, I could show that first value of the sales order detail ID is 11, and the last one is 7, because again, I ordered by price. And so in this window here, the first is 11, the last is 7. I did that on purpose to show that it may not always be the largest or smallest value. It may not always be the min or the max. It's just the first and last value from your window, which can be very useful. If you're ordering by date, give me the first order value from the first one I ever got in my window, or the last one. How about lead and lag? Lead and lag are really useful. These are cool. I'm including additional syntax here. Note that I put a 1 here. This means the offset is 1. Go back, run 1 row, or go forward 1 row. So I can look here in my window and see that for each row, the prior unit price is here, and the next one is here. So for example, the prior is that one. The next will be the next one. Obviously, if we're in the first row of a window, the prior value is null, doesn't exist. If you're at the end of a window, the next value is null. So just keep in mind that your prior at the beginning and the next value at the end will be null because there's nothing to evaluate. Just keep that in mind. You can is null it if you want to get rid of it if you need to. You don't have to. Similarly, I did it by sales order detail ID for fun here. And same thing, I got the previous and next values. So this can grab out of your window prior values and next values. And we can do more. We can customize this some more. I can offset by 2. So if I put a 2 there, I will go back 2 values or ahead 2 values. So for example, for this row, I can see that the prior one offset by 2 is 2 rows back. The next value offset by 2 is 2 rows forward. I have more nulls now because 2 rows back is nothing for these two. It doesn't exist. Same for the 2 leading rows down here. Just keep in mind that the more rows you offset by, the more nulls you'll end up with, which again, this might be fine. You may not care, but just be aware of that. You can put defaults in if you want. You don't have to is null it. You can, if you want, add the third parameter in. I put 0 in here. You may or may not want to do this. Maybe you do. If you do, then I run this and I can see that I put in zeros. And so the prior here, which normally would be null, is now 0. And then the next over here is also 0. You may or may not want this, but if you want a default value, you can put it in. It's that third parameter there, the third value. So you have your lead and lag, you have the column that I want to evaluate, how many rows I want to offset by, and then if I want to default to get rid of my nulls here, what will it be? And it must be positive, by the way. You might be thinking, what if I do -1? -1's a great unifier, right? It gets rid of all the weird, it won't let you. It's got to be a positive number. Sorry. I tried it too. I put -1 in here. I got a chuckle at the error message. So you can't put -1 in there. It's life. You can do stats, as always. We can do things like standard deviations and variance. I noted the difference here between each of these. There's a slight difference between standard deviation and standard deviation for population, and variance for population. The difference is really just one in the denominator. When you do a standard deviation or variance, it's assuming you only have a subset of a population. You have a data set that is incomplete, and therefore it's going to make a slight adjustment to it. If you do the population version of it, it assumes you have the whole data set and it won't make any adjustments. It's a minor statistical note. It's something you can read about and learn about. I'm not going to really go into that here because we only have 5 minutes and this is not a stat session, but they're both available depending on what you need. I do want to demo it. Demos are fun. Not going to spend a lot of time on this demo. I do want to have time for questions at the end. But you can see here that it very quickly calculates standard deviations and variances. And you can note there is difference between the population version and the standard version. So just keep that in mind. There are 2 versions for each. They're different. I did, for fun, use my Windows syntax, unbounded, preceding, and following. So please give me a standard deviation for the whole data set, not a running standard deviation. That wouldn't really make any sense. I'm not even sure if you can do that. But again, same for variance. The values differ, and they provide you information about your data set. So if you're looking for stats, you can calculate them here, and that's cool. Now, there's a question here that you might be thinking, that I'm thinking, and that is, where should I do this? Is it better to calculate my stats, my analytic measures, and so on in SQL Server, or should I do it in an application? Should I do it in some dashboarding app or in some tool or use Python somewhere else? And the answer to this question that I typically give is going to be, do you need that detailed data elsewhere? Do you need to actually have all that detail in your dashboard, in your app, for your machine learning, whatever else you're doing? Do you need it? If you need it, then it doesn't really matter that much where you calculate it. You can do it here or there, and it's really up to you. But if you don't need it, it might be better to calculate it in the SQL Server and deliver less data back to your app. That's a big difference. Or do what's more convenient. If it doesn't matter to you, if it doesn't make a difference, you can simply do what's more convenient for you, what performs better. Some people like having, for their analytics, having all your stats available up front. That means that you don't have to do any additional work or calculations and everything's ready to go, and you can simply display it, show it, work with it. Other people prefer to do all the calculations in your visualization application or whatever. And again, this is up to you. Performance does differ, though. Performance of doing these calculations in SQL Server may differ from Python or Fabric or somewhere else, wherever you pull your data. So just keep in mind that it may be faster or slower in one place over the other, and that might matter to you. How about performance? Another common question. There's no free lunch. This doesn't make things magically fast. You still have to read data from storage into memory and then do things with it. And if you have partition by and order by, you're going to be aggregating your data and ordering your data, which can be expensive. So just keep in mind that there's no freebie here. I still have to take my data from each window and do things with it. I have to read it. But if you have a lot of window functions over a single data set, you'll find that you'll get better performance because I don't need 10 queries anymore. I can have 1 query. And that 1 query might have a lot going on in the execution plan. It might be a little big, but it's still probably more efficient than reading a data set 10 times, because scanning a data set 10 times is more expensive usually than scanning it once, even if I've got to do a bunch of stuff in there with my data. But you can confirm all this. You can use your execution plan, stats.io, query store, whatever extended events you want to use to validate what's more efficient. In general, I would say do whatever is easiest until performance dictates otherwise. That's generally my philosophy, is do what's most natural, that makes the most sense for your analytics. And then if performance is an issue, fix it later. And this is analytics, so you have a little bit of leeway. Don't over-optimize up front. You can do that later if you need to. And for this world of calculations, I'm cool with that. So I want a little bit of time for questions here. a few minutes, so I'm going to wrap up here. The goal of this presentation was really to introduce and demo heavily, and have some fun mistakes along the way, window functions, and show how versatile they are, how much they can do. They can do a lot. They can do far more than I even demoed today. They can do so much. If you can dream it up, they can do it for you. And if you have trouble figuring it out, lots of docs, or feel free to just message me sometime and say, hey, Ed, do you have an idea for this? And I'll reply. I do that. It's fun. It's cool. I love chatting with people about problems and data and solving them. Always be sure to test, though, your analytics. Test and make sure that your values are correct, that your window is correct. If you're doing rows, unbounded, preceding, following, whatever, make sure it's correct. If you don't use that syntax, make sure the assumed window is correct. And also note that new versions of SQL Server have more toys to play with. They have more window functions, more features, more options. There's approximate functions you can use. There's additional ones I didn't even demo today. So if you need more things that I didn't mention, they might very well be out there, or they'll be out there soon. So keep an eye out for new features as well. With that, I want to kind of wrap up, breathe for the first time in 50 minutes, and open it up to questions. My info is here. Feel free to contact me if you have questions. I will post on LinkedIn the demos, the slides, everything else. I'll clean up the demos, by the way, first before I do that. And if you have any questions, you can feel free to ask.